Okay, in this problem, I'm going to show you how you can use an indefinite integral to solve the problem of computing a position function given the velocity function as well as the initial condition on the position. So we have an object that's moving at a certain velocity, this velocity, 126t minus 6t squared feet per minute, where t is minutes. And we also know that at time 0, the object has not traveled at all yet, so the position at time 0 is 0 feet. So we're going to use these two pieces of information to obtain the position function. And once we have that, then we'll find the total distance traveled after 12 minutes by substituting t equals 12 into our position function. So the position s of t is the indefinite integral of 126t minus 6t squared dt. So using the fact that the indefinite integral is linear, I can separate this into two integrals and pull out constants. So it's 126 integral of t minus 6 times the integral, whoops, forgot to do t, don't forget that, minus 6 times the integral of t squared dt. So you can always pull apart sums or differences like this, not products or quotients, only sums and differences. So now we have the integral of t squared, both fit the power rule for integration. So the integral of t is t squared over 2, because you increase, because t is the same as t to the first power. So we increase the power by 1, and then you divide by that power. And we do the same thing over here, so minus 6. Integral of t squared is t cubed, and then divide by the new exponent, divide by 3, plus c. So now, if I simplify that, I get 126 divided by 2 is 63t squared minus 2t cubed plus c. Now, c is some constant. I have to choose the constant c so that when I substitute in t equals 0, I will actually get 0. So, but if I substitute in t equals 0 here, all that's left is c. And I need c, so I need that to equal 0, therefore c must equal 0. So I can conclude that my position function s of t is just this part here, 63t squared minus 2t cubed. So if I was given a different value for the initial position, s of 0, I would set this equal to that, and c would end up equaling whatever value that is. So now this is my position function. So position after t minutes is equal to s of t feet. So now I will substitute t equals 12 into that position function. So I have 63 times 12 squared minus 2 times 12 cubed. Okay. So in this case, yeah, I think I would need a calculator for this. So 12 squared is 144, so 63 times 144 is 9,072, minus 12 cubed is 1,728, times 2 is 3456, and we get 5616 feet. So after 12 minutes, the object traveled this velocity has traveled a total of 5,616 feet. All right. So for initial value problems like these, for given the velocity, or really which is a derivative of position and the initial value, take the integral of the derivative that you're given, and you get the form of your function. You just have this plus c. So then you set your value of t in this case, or it could be x, whatever independent variable you have. That's when you substitute this value for that variable, and then you set the result equal to the value on the right side here. In this case, both happen to be equal to 0. And what that will do is give you an equation for c, and you solve that for c. In this case, c turned out to be 0. So once you have your position function, then you can just substitute whatever value of time in there to obtain the total distance traveled after that amount of